All right, here's another question. Does anyone know why ASICs and FPGAs are the go-to choices for AI and ML workloads? So why are ASICs and FPGAs so popular when it comes to AI and machine learning workloads? Well, let me answer that for you. So AI and machine learning workloads, especially neural networks, involve massive amounts of math, mostly matrix multiplications and vector operations done repeatedly and in parallel. So hardware that can do high speed math operations, hardware that can do massive parallel processing, hardware that's energy efficient in their execution. That is what is considered ideal. So ASICs, or application-specific integrated circuits, they've been around for a long time, and what's good about them is that they are custom built for a specific task, like training or running AI models, right? So they can be hyper optimized for the exact math, memory needs for the workload, right? They're used in large scale data centers. So you think about Google's TPU, that's an ASIC, or you think about NVIDIA, some NVIDIA's chips, a lot of those are ASICs because of that. The big advantage is they're very high speed and high performance for specific workloads. And they're lower power consumption per the operation. So when it comes to scaling, and when we're talking about AI and when we're talking about machine learning, we're talking about scale, really large workloads, they can do that. They also have a smaller physical footprint, at scale. Now, the trade-off for ASICs is that they are expensive and time-consuming to develop, because again, you're building that custom for a specific thing, right? The other thing is that it's a fixed functionality, right? So it's built for that fixed functionality, and it's not really adaptable. Now, the other chip that I mentioned at the beginning was FPGAs, field programmable gate arrays. So what about these guys? Well, they're the opposite of the ASICs, is that they are reconfigurable hardware. So you can customize the logic in these chips after manufacturing. So they're ideal for low latency, edge AI, or where hardware needs to be tweaked often. And they're often used in telecom, automotive, and embedded in AI systems as well. So the advantage with FPGAs is that they're faster than general CPUs for AI ML because they can do parallel processing. They're more flexible than ASICs, right? Because you can reprogram the chip's logic. So they're good, especially in scenarios where you're prototyping custom architectures. So some of the trade-offs is with FPGAs, they're slower and less efficient than ASICs, but more programmable. But when you compare them to CPUs, they're harder to reprogram than CPUs, but they still can handle more parallel processing, etc., at scale better than CPUs.